Hello everybody, hi. This is Tommy Tsunami coming to you from High Touch High Tech in New Jersey. And we are going to do another cool science lesson today. Today we're going to talk about the science of physics and what you call forces and how forces can be used to do so many different things. Particularly when you push something, you're going to get an equal and opposite reaction pulling it the other way. So if you pull something down, you're going to get an equal opposite reaction pushing a force going the other direction. So today we're going to design an instrument that was used 1,000 years ago or more to show how you could use the forces to move large objects and to move them in way more than you could do with using the force of your hands or force of people, okay? So today we're going to design what's called a catapult, okay? And a catapult was used in medieval times to go and break into castles, and people used to use, different people use them to go and break down a castle wall of your neighbor who you didn't like or something like that. And they use them military, they use them to move large things. And a catapult can take a rock and move it far and long distances. And a catapult uses two different things that are common in physics, and they're called a lever and a fulcrum. And another object that you're more familiar with these days that uses the same principles is called a seesaw. And in a seesaw you have a lever, which is the board that you'll be sitting on, and a fulcrum is the point that the lever rests on, that you use the force of one person who's sitting on this end is going to move the other person sitting on the other end. And if you've ever been on a seesaw, which I imagine hopefully you have, you know that if somebody's really big on one end, it's going to make the other person go up more, and the other person who's light on the other end is not going to make the other person go downward, because you have different amount of weight on different ends. But if you have two people who are similar weight and they go on the seesaw and they push downward, the other one goes up, the other one goes up the other direction, one goes down, one goes up, and you use that on the lever on the fulcrum. So let's go and make our catapult, okay? So to make our catapult, you need two large popsicle sticks like this. You need 7 of these smaller regular popsicle sticks here. And I have an assortment of rubber bands, different size rubber bands that I'm using. And what's important is we need our spoon, okay? So to start making the catapult, you take your spoon and one of your large popsicle sticks, and we want to attach the spoon so it goes to about the end, so where it starts curving off. Before it starts curving off, when you attach it to the spoon using small rubber bands. So I'm using these small rubber bands like this, and I'm stretching them on here. And I'm using it 2 or 3 to make sure that the spoon stays on there nice and tight. Let me get this one on here, like this, and twist it up, and you can see that the rubber bands are attached to the spoon, and that the spoon is really tightly against this large popsicle stick here, okay? So now we take our other smaller popsicle sticks, the 7 of them, and we make a stack of them, okay? We're gonna stack them up all together like this. And what I do is take one of the rubber bands, like the regular size rubber band here, and I'm gonna bring it on here. Whatever size rubber band you have, you want to make it tight, okay? So you gotta twist them around enough times so you get it nice and tight here. Now before I put the other one on, I want to show you that take the other large popsicle stick and put it between the last one and the next to last one here. Just put it in between there like that, so it goes in like that. And then just attach your other rubber band like this, okay? Make it really tight again. So now you have popsicle sticks in here, attached to the one large popsicle stick on this edge, on the next to the last one. Okay, now to finish the catapult, we take our spoon again with the other popsicle stick, and we take a nice big rubber band like this, if we have it, because this one is going to do all the stretching here. And we make it nice and tight around here on the end of it here. Keep them nice and keep them together like this, so they're really tight. Now you have a catapult, okay? And just like our seesaw before, we have a lever and a fulcrum. And the lever is the spoon on the stick, and the fulcrum is this point here, wherever the stick is resting on this. And this fulcrum can be moved, and we'll show you how that changes how the force works here, okay? So to start off with this, I'll get this rubber band back up here a little bit, okay? We're going to show how this catapult can use force to move different objects. So we have different balls here of different sizes and different weights. So we start with our regular pom-pom here. Put it on the edge of the catapult. I like to hold, push down on the edge of the popsicle stick, not on the spoon. You could do it on the spoon, but it's better to push down on the edge of the popsicle stick so you get the most force. Get that all the way down to the table while you're holding this end with this finger here, and push down on that finger, and whoa, a lot of force on there, okay? Let me get that back. Now I'm going to show you what happens when you move the fulcrum, okay? Take the fulcrum here, push it over towards the end like that. Notice you have less of an opening here. You have smaller opening here than you did before when it was like that, okay? So now I can't push down as far as I did before, but I can still push down. It goes high, but not as high as it did before, because when it's here, I'm able to put more force into this. I'm able to push down further and get more force into that. So remember, the force that you push down equals the amount of force that's going to push that object outward, okay? So let's get this lined up again. Now, force, the amount of force is going to determine how far this object goes, but also the weight of that object determines how far it goes as well. If I take this object, which is a wooden ball, this wooden ball weighs more than the pom-pom does. It's heavier than the pom-pom, not very much heavier, but heavier. And I have this all the way here where I started from before, and I push it all the way down to the table. It goes pretty high, but not as high and as fast as the pom-pom went, because the pom-pom's a lot lighter. And take this ball here, which is like a super ball, put it on the edge of the catapult. Again, push it all the way downward the same way. Definitely doesn't go as high. And the reason for that is you need more force to push more weight, more mass. The more force you have will determine how far an object goes, but the more the object weighs, the more force you need to push that object the same distance, okay? Does the size of the object matter versus the weight? Let's take a look, okay? So we have these two pom-poms here, and this pom-pom we saw went very far. This pom-pom weighs about the same or a little less than the other one. So I'm going to push this down here, same way, and that goes pretty good. And this one here, which is definitely bigger than this one, but these are very similar in weight, and this I can push down, and yes, so that one is more compact and it's similar to this one. It goes pretty far, but does he need a ball to go or something round to move? No, you could push whatever. And we're going to see how dinosaurs can fly now. I'm going to put that in the edge of the catapult, and it weighs about as much as the pom-pom, and push, and whoa! We get a lot of movement on that dinosaur because he's able to put a lot of force into that, okay? So remember, the force in equals the force out, and the force is affected by how much the object weighs. And if you push this to the edge of here, you could get it to go really far. If you get the spoon to go off the edge of your table like that, you could even get it to go a little further. Okay, and remember, where you put the fulcrum matters, because where you can get the most force is where you get more ability to, more space in between these two sticks. You get more force coming out when you have more movement. Okay, so guys, I hope you get to build this catapult and try it on different objects at home and make sure nobody's in the way when you're shooting it. And when you're using a catapult, you are using the science of physics and using science that's been around for 1,000+ years, and to move different objects at different speeds and different distances. So, guys, thank you. I hope you enjoyed making your catapult and get to try it on different things at home. Again, thanks, guys, for coming with us, joining us today. Thank you.